Hey guys, welcome back. Keep forgetting about this. Okay, sorry. If I unplug my computer from my TV, then it doesn't glitch as much. All right, so today we are going to look at writing equations. Today's Tuesday. We're going to look at writing equations. I'm going to go through the notes. Today you're going to answer the exit ticket. It's going to be a grade. And then I am going to work through a couple of the equations at the end of this video to help you for the assignment tomorrow. Okay, so today we're going through the notes, so you need to make sure your notes are up to date and then do the exit ticket. And then tomorrow there's going to be an activity and I'll work through a couple of those problems with you at the end of this. So go ahead and go to your journal. You should have your journal. All your notes should be in your journal. Make sure your journal's up to date. There will be a journal grade at the end of the 9 weeks. I'm not giving you my journal this time. Excuse me. So make sure you have it up to date. Sorry guys, I just was eating lunch. Okay. So today we are looking at Unit 4, Lesson 5. And we are writing equations, writing linear equations. Linear equations. There we go. And this is, link it to, I think it's going to be slide 15. Let me double check. 14, 15, yeah. So slides and presentation. Slide, just scroll down until you see slide 15 and apply. So that makes it to where you can just click on here and it will take you to slide 15. Okay. All right. So like I said in a couple of videos ago, this unit is a lot about application. So it's a lot of real world situations. That's what we're talking about. So we're applying the things we've been learning all year long. Well, when are we going to actually use that in the real world? These are real situations. Okay. So here we go. Jennifer wants to have flyers printed for her upcoming car wash fundraiser. Henderson Printing charges a $10 design fee, and $2 per flyer. Okay, so Jennifer's going to have a car wash. She's raising money for, I don't know, her sick grandma or something. I don't know. She's raising money. Okay, usually we have fundraisers to help people that are sick, or maybe an organization. Maybe she plays soccer. She's in a soccer league and they're trying to raise money so they can buy uniforms this year. Okay, but they're having a car wash to raise some money. This is something we can see ourselves doing all the time, right? All the time, Texas Bank has got car washes going on in their parking lot. So she's having a car wash. Henderson Printing is going to charge her a $10 design fee and $2 per flyer. So my first task here is to write an equation that represents the total cost T in terms of the flyers F. Okay, so before I write my equation, I want to come down here and I want to just define my variables. Well, it told me that T is supposed to represent the total cost. So I'm going to say T represents the total cost. And then we are going to use the variable F to represent, this says flyers. So I'm going to say that F represents the number of flyers I'm buying. So number of flyers. Okay. So I want to write an equation, T equals, how am I going to find my total cost? So I know that I'm going to be charged a $10 design fee. So do I have to pay that $10 for every single flyer? Or do I just have to pay that design fee one time? Well, design fee, typically, once you pay it once, then you have that design forever. So you don't have to, like, I can purchase a design fee from somebody and then print my own flyers at home. So normally you would just have to pay for that design fee one time. That's a one-time fee. Normally when you have some kind of fee, if you're looking at these problems, if it says design fee or service fee or anything along those lines where you have a fee, that's just a one-time payment. Okay, so we have $10, or I'm just going to use 10. So we're paying a design fee, and we're paying a $2 per flyer. So, and the word and means we're not just paying $10 and then subtracting money off, right? And means add. We're increasing the amount we're going to have to pay. So, and means plus. I'm going to go ahead and put some spaces here. Oops. There we go. So we're paying $10 and means add $2 per flyer. So are we only paying the $2 once? No, we're going to pay $2 for every single flyer. So if we buy 100 flyers, how much are we paying for those? Well, for 100 flyers at $2 a piece, that's $200, right? So how did we figure that 200 out? Well, we did 2 times 100. Okay, so how do I write that in words? Well, 100 was the number of flyers, and we wrote down here that the number of flyers is represented by F. So I did 2 times 100. Instead of using 100, because we could order 50, or we could order 75, or we could order 1,000. Instead of using a number there, I'm going to use a variable because it can change. And we said our variable for the number of flyers we're purchasing was F. And I'm going to write it right beside that number 2 because that's multiplication. We said we would do 2 times 100. So I'm going to do 2 times F, and that F can change. That's what variables mean. We can order as many flyers as we want or as few flyers as we want. We don't know exactly how many we want to order yet. Okay, so that's why we're using a variable in this place. So my equation is T. I need a space here. That's bothering me. Okay, T equals $10 design fee and $2 per flyer. Okay, so now let's look at this. Well, we wrote this in the form y equals kind of mx plus b. We wrote it as y equals b plus mx. So I'm going to rewrite this as t. This is the same thing saying t equals 2f plus 10, right? Now it looks like y equals mx plus b. I have variables there. So my m is the number that's right in front of my variable f, which is 2. So my rate of change is the same thing as slope. My rate of change is 2. And what did that mean? In this problem, what is the 2? Well, the 2 is the amount of money I'm paying per flyer. So this is cost per flyer. We're paying $2 for each flyer. Then my y-intercept, my plus b here is 10. Or I would write that as an ordered pair as 0, 10. Right? My x value is 0, my y value is 10. And what does this represent? So what does my y-intercept mean? Well, this is my $10 design fee. So this is my design fee. And this is the amount, my base amount. This is like the base cost. This means that, like I said, I could go to somebody and say, hey, I need some flyers. Do you mind making my flyers? Do you mind making a design for me? And they'd be like, yeah, sure. I'm going to charge you $10 for the fee for the design. And then I can print them for you for $2 each. But I might decide like, no, $2 a piece is too much. I've already got paper at home. It's already like, I just need the design. I can print it myself. So I have to pay that person whether I buy flyers from them or not. I need to pay them for their work of making the design. Okay, so that's why we have this y-intercept. This is our base cost. So even if I don't buy any flyers, I still have to pay them $10 because they made the design for me. They created the flyer for me to print. Okay, so that would be my design fee, my base cost. My starting cost would be $10. All right, so this last question says, how much will it cost if Jennifer places an order for 60 flyers? So you're gonna put a picture of your work here. But this is one way we can do this. Let me open up my iPad. I'm not ready again, guys, sorry. One way we can do this is say, well, 60 is the number of flyers we're buying. So that's gonna go in place of F. F is gonna be 60. And then there we go. Okay, so F is going to be 60, and I can put that in my equation in place of F. It's going to pop up. So let me get my equation here. My equation is T equals 2F plus 10, and we're saying, oh no, are you going to die? Okay. We're saying that F equals 60, so I'm going to open this up. One way to do this is by doing this. Okay, so T equals 2F plus 10, and we're saying that F is going to be 60. So that means what I'm really doing is T equals 2 times 60 flyers plus $10. Well, 2 times 60 is 120, plus 10 is 130. So my total cost for 60 flyers is $130. Another way we could do this is by using Desmos. Okay, go away. Is by using Desmos and function notation. So earlier this year we talked about function notation. And if you remember how to set up function notation, then you can use Desmos and it will do this for you. So here we could type in our equation, f of x, instead of using, let me come back over here. Because Desmos will only graph things that are in the form using x's and y's, instead of writing t, I'm going to use f of x equals 2, instead of using f, I'm going to use x plus 10. Okay, so this is the function I'm going to write. All I did was change this t out for f of x, and I changed my f out for my input variable, which was x. Okay, so f of x equals 2x plus 10. So here's the line that represents the function I'm talking about. And we see our y-intercept is in fact 10, and we could figure out our slope is actually 2. So we rise 2 over 1. There's our slope, okay? So now I want to know when x is 60, how much do I have to pay? So I could type that in, f of 60. I could use my function notation that we learned earlier this year, and it tells me 130. And that's what I got when I worked it out over here, right? I got 130, okay? So let's see. I'm going to go ahead and, what did I do? Oops. There we go. Hit the wrong button. I'm going to take a picture of my notes, and I'm going to come over here to my, nope, that's the wrong thing. Here we go. I'm going to do insert, move my picture here over. Insert image, upload from computer. You guys can use insert image from your camera, and you can just take a picture of your notes that you wrote down. And no, this should be a screenshot. Is that it? Nope. Oh, I'm on the wrong thing. It's going to be on my desktop. Here we go. Okay. There we go. Okay, so we've got my notes there. All right, there's one more problem, and then you guys are going to have an exit ticket to work on. Okay, so Greg wants to empty his hot tub to clean it. He has a 300-gallon hot tub and empties it at a rate of 20 gallons per minute. So write the equation that represents the gallons of water in the hot tub, G, in terms of minutes, M. So G, before I write my equation, I'm going to go ahead and write out. Think about, what does G represent? Well, G represents the total gallons of water. And M represents the number of minutes. Okay, so I'm going to write this. G equals, so the number of gallons equals, how many gallons did he start with? Well, he started with 300 gallons, and he's draining it. So are we adding water or are we subtracting water? Well, draining it means, like, if you drain your bathtub, water's going away, right? So we're subtracting water. He's emptying it. So that's how we're getting subtraction, empty. It's going away. And it's emptying at a rate. Rate of change is what? Slope. Slope. So anytime you see the word rate, connect that to slope. Okay? So it's draining at a rate of 20 gallons per minute. The word per means multiplication. And we said we're using M for the for the number of minutes. So he's starting out with 300 gallons, and it's going down at a rate of 20 gallons per minute. So 300 minus 20 times M. So here again, our rate of change, well, it said rate was 20 gallons per minute. And what does this represent? Well, we're losing gallons, right? That's, negative 20, that's negative slope. We're losing gallons of water. So this is draining, basically told us this answer in the problem, right? What does it represent? Well, we're draining water at 20 gallons every minute. Every minute. There we go. Okay, so then my y-intercept, well, if I have it written in the form y equals mx plus b, the y-intercept is the thing that doesn't have the variable with it. So my y-intercept is, let's write this as an ordered pair. My x value is 0, y value is 300. My y-intercept is 300. And what does it represent? Well, 300 was the gallons of water in his hot tub. So total gallons of water, I'm going to say in the beginning, before he started draining it. That's where he started with. So the number of gallons he started with. So how many minutes will it take the hot tub to drain is what we want to know. So this problem, we have G equals 300 minus 20m. And I want to figure out an m. I don't know what my m is, but I know I want it to be completely empty. So that means I need this number to be 0. I want my G to equal 0. Okay, so let's go ahead and plug that in. We have if our gallons is 0, then how long did it take me to get there? I can solve for m. I can figure out that time. So the first thing I'm going to do, I'm going to get m by itself. So the first thing I'm going to do is subtract 300 from both sides. I'm going to draw my line over here. So 300 minus 300 is 0. That leaves me with negative 20m equals negative 300. Then I can go ahead and divide by negative 20. And negative 20 divided by negative 20 is 1m. And I don't have to write that 1 in front of my m. I can just write, if I write an m, I know there's one of them. Then I have 300 divided by 20. Well, 300, that's negative 300. So negative 300 divided by negative 20. Type that in my calculator, and I'm going to get 15. That makes sense. 20 goes into 100 5 times, right? 5 times 3 is 15. So it took me 15 minutes. So 15 minutes to drain the tub. All right, again, I can take a screenshot of my work. I can come over here, do insert image. I'm going to upload it from my computer. It'll be right there. All right.